Apache Kafka. If you work anywhere near data engineering, you've heard this name. But what exactly is it, and why does every company seem to use it? In the next 5 minutes, I'll break down Kafka's core concepts using 3 simple diagrams. By the end, you'll understand Kafka better than most people who use it daily. Let's go. First, what's a message queue? Imagine System A needs to send data to System B. The simplest way is a direct connection. But what if B crashes? What if A sends data faster than B can handle? What if Systems C and D also need that data? A message queue is a buffer in between. A puts messages in, B reads them out. They're decoupled. Kafka is the most popular distributed message queue. Built at LinkedIn, now an Apache project. It handles millions of messages per second. Here's the big picture. A Kafka cluster has multiple brokers. Each broker is a server. Producers send messages to brokers, consumers read from brokers. Messages are organized by topics, like channels. Ordered data goes to the orders topic, logs go to the logs topic. Each topic is split into partitions. Partitions are the key to Kafka's performance. Data is spread across partitions for parallel processing. First diagram. How do producers send messages to partitions? Say you have a topic called orders with 3 partitions, 0, 1, and 2. When a producer sends a message, it can specify a key. Kafka hashes the key to decide which partition gets the message. For example, using user ID as the key means all orders from the same user go to the same partition. This guarantees ordering per user. Each message gets a unique offset within its partition, starting from 0. Remember, Kafka guarantees order within a partition, not across partitions. Second diagram. Consumer groups. This is Kafka's most elegant design. Multiple consumers form a consumer group. Within a group, each partition is consumed by exactly one consumer. No duplicates. 3 partitions, 3 consumers, perfect one-to-one mapping. If a consumer dies, Kafka automatically reassigns its partitions to other consumers in the group. This is called rebalance. Different consumer groups are independent. Each group gets all the data. Same group equals load balancing. Different groups equals broadcast. Brilliant. Third diagram. Replication. This is how Kafka prevents data loss. Each partition has multiple replicas spread across different brokers. One replica is the leader, handling all reads and writes. The others are followers, just syncing data. If the leader's broker crashes, Kafka promotes a synced follower to be the new leader. The list of in-sync replicas is called the ISR. Typically you set replication factor to 3. 1 leader, 2 followers. You can survive 2 simultaneous broker failures. Why can Kafka handle millions of messages per second? 4 reasons. 1. Sequential disk writes. Kafka appends messages to log files. Sequential I/O is nearly as fast as memory. 2. Zero-copy technology. Data goes from disk to network card without passing through user space. 3. Batch processing. Producers batch messages together, consumers fetch in bulk. 4. Partition parallelism. Multiple partitions read and write simultaneously. These 4 designs together make Kafka incredibly fast at massive scale. Where is Kafka used? Log aggregation, collecting logs from all services into one place for search or analysis. Real-time stream processing with Flink or Spark streaming, think real-time dashboards and fraud detection. System decoupling, services communicate through Kafka instead of direct connections. And peak shaving, during flash sales, requests queue in Kafka so backend services process at their own pace without crashing. Let's recap with 3 diagrams. Diagram 1, producers hash message keys to distribute across partitions. Offsets guarantee order within each partition. Diagram 2, consumer groups enable both load balancing and broadcast consumption. Rebalance handles failures automatically. Diagram 3, leader-follower replication with ISR ensures zero data loss. Remember these 3 diagrams, and you understand Kafka's core. Thanks for watching. Like and subscribe for more data engineering explainers. See you next time.